And welcome back to our YouTube channel Gurmantra Shiksha Ka Granth. I am your educator Nidhi Dua and I teach you chemistry at this platform. Hope you all are doing good, you all are fit and fine and your studies are going in a smooth manner. So without any further delay, let's begin our today's topic, that is chemistry of group 2 elements. Today in this lecture we are going to study about some compounds of group 2 elements. Number 1 is your calcium oxide, that is also known as quicklime. Calcium oxide, commonly known as quicklime or burnt lime, is widely used chemical compound. It is a white caustic alkaline crystalline solid, that is crystalline solid at room temperature. By the contrast, quicklime specifically applies to a single chemical compound, calcium oxide. Calcium oxide that survives processing without reacting in the building products such as cement is called free lime. Talking about the preparation method of calcium oxide, of CaO or of quicklime, that is, you can get calcium oxide by heating limestone at 800 degrees Celsius. This is very important to note down that if you want to prepare calcium oxide, you have to heat the limestone at 800 degrees Celsius. You have to learn the temperature. Next, about the properties of calcium oxide. When you react calcium oxide with water, you will get a compound that is CaOH whole twice, that is known as calcium hydroxide, and the paste of calcium hydroxide in water is known as milk of lime. This is also very important. You need to memorize all the terminologies teaching in you in this video. Next is the basic nature. When you react calcium oxide with SiO2, you will get a compound that is CaSiO3, and that shows the basic nature. Next, when you react 6CaO with P4O10, and when you heat this mixture, you will get a compound that is 2Ca3PO4 whole twice. Third is the reaction with carbon. When CaO reacts with 3 moles of carbon and this reaction is heated, you will get a compound that is calcium carbide, and plus carbon monoxide formation takes place. You have to learn all the reactions. These reactions will help you to solve all the questions in your exam. Next, the uses of calcium oxide in the manufacture of bleaching powder, cement, glass, calcium carbide, etc. Second is the purification of sugar. In the purification of sugar, calcium oxide helps, and this calcium oxide acts as a drying agent for NH3 and ethanol. This is also used in the making of soda lime. Next is the calcium hydroxide. Calcium hydroxide is commonly called slag lime. It is an inorganic compound with the chemical formula CaOH whole twice. This is colorless crystal or white powder, and it is produced when quicklime is mixed or slagged with water. It has many names including hydrated lime, caustic lime, builder's lime, slag lime, cal, etc. This calcium hydroxide is used in many applications including food preparations, where it has been identified as a E number, that is E526. You only need to learn the E number for calcium oxide, and that is E526. This is very important. Now, next is the preparation method for the calcium hydroxide. You can prepare calcium hydroxides by the action of water on quicklime, that is CaO plus H2O reacting together will form CaOH whole twice and heat is liberated. Properties are, when you react calcium hydroxide with CO2, this will turn lime water into milky and this will produce a compound that is calcium carbonate and water molecule is liberated or generated. So this is the important reaction of calcium hydroxide. Next, when you burnt CaCO3 in excess of carbon dioxide, you will get a compound that is CaHCO3 whole twice. Next is the action of chlorine. When you react calcium hydroxide with chlorine below 35 degrees Celsius temperature, you need to remember, you need to memorize this. You have to react chlorine gas with CaOH whole twice below 35 degrees Celsius temperature. Only then you will get this compound and this is your bleaching powder formula. When I repeat, when you react CaOH whole twice with Cl2 below 35 degrees Celsius, you will get bleaching powder. And 2 CaOH whole twice plus 2 Cl2 in presence of red heat, you will get 2 CaCl2 plus 2 molecules of H2O and plus oxygen gas. Next, the uses of calcium hydroxide. This calcium hydroxide is used for the softening of hard water, for the purification of sugar and coal gas. Third is in the manufacture of bleaching powder, caustic soda and soda lime, and in the preparation of mortar, plaster and whitewashing. Third is calcium sulfate. Calcium sulfate has the formula CaSO4, while its hydrate has the formula CaSO4.2H2O, that is known as gypsum. Calcium sulfate is the inorganic compound with the formula CaSO4 and related hydrates. In the form of gamma anhydrate, it is used as a desiccant. One particular hydrate is better known as plaster of Paris and another occurs naturally as the mineral gypsum. It has many uses in the industry. So, calcium sulfate has the formula that is CaSO4, while its hydrate has the formula that is CaSO4.2H2O and known as gypsum. Talking about the preparation method of calcium sulfate or gypsum, this hydrate of calcium sulfate is naturally occurring, that is your gypsum. It can be obtained by the action of dilute H2SO4 on a soluble calcium salt below 60 degrees Celsius. You have to learn this point that when you react CaCl2, when you react calcium salt with a dilute acid, that is H2SO4, below 60 degrees Celsius, what you will get CaSO4 plus 2HCl. But this temperature should be minimum. This temperature should be minimum than 60 degrees Celsius or below than 60 degrees Celsius. Next is the properties of calcium sulfate. When you heat up the calcium sulfate, the hydrate of calcium sulfate at 120 degrees Celsius, what you will get? You will get CaSO4.2H2O. This is your CaSO4, but also CaSO4 whole twice dot 2H2O, and that is your plaster of Paris. 1 second. There should be half molecule of H2. Then only you will say this is plaster of Paris. When you heat up this at 200 degrees Celsius, you will get 2 CaSO4, that is your calcium sulfate. This calcium sulfate also forms an important fertilizer, that is NH4 2 SO4. This is also very important point, and this was your PYQ of GATE. Next, the uses of calcium sulfate. Calcium sulfate is used in the preparation of plaster of Paris or POP. This you will study in the next slide. Anhydrous CaSO4 is also used as the drying agent. Anhydrous CaSO4 is used for the manufacturing of sulfuric acid and ammonium sulfate. This was all about calcium sulfate. Next, what we are going to study about is plaster of Paris. So, as I have told you, the formula for plaster of Paris is 2CaSO4 dot half H2O. This molecule should be half. Plaster of Paris quicklime setting gypsum plaster consisting of a fine white powder calcium sulfate hemihydrate which hardens when moistened and allowed to dry. This is known since ancient times, and plaster of Paris is so called because of its preparation from the abundant gypsum near Paris. Talking about the preparation method of plaster of Paris, it is obtained when gypsum is heated at 120 degrees Celsius. When you heat up gypsum at 120 degrees Celsius, you will get the plaster of Paris. Properties of plaster of Paris are these. It is a white colored powder. It has property of setting to a hard mass when a paste with water is allowed to stand for some time. Next, the uses of plaster of Paris is in making casts for toys, statues, etc. and in making blackboard chalks. Now, I hope you all are cleared about the group 2 elements compounds. In the previous videos, in the previous lectures, we have covered the physical and chemical properties of group 1 and group 2, the anomalous behavior of lithium, and in this lecture we have covered the group 2 compounds. And now, we are going to study about the anomalous behavior of beryllium. So, number 1 point is, it is the hardest of all alkaline earth metal. As maximum metallic bonding is present due to the smallest size. That's why it is the hardest of all alkaline earth metal. The melting and boiling point of beryllium are highest. I am highlighting all the important points. The melting and boiling points of beryllium are the highest. This is least reactive. In case of beryllium, beryllium is least reactive due to the highest ionization energy or highest ionization potential. Due to high charge density, its polarizing effect is highest and also forms covalent bond. Due to its small size, it has strong tendency to form complex. In group 1 elements, you have studied that lithium has the only tendency to form a complex compound due to its small size, and also beryllium has the tendency to form complex. And this beryllium shows a direct diagonal relationship with aluminium. Next is the biological role of sodium, potassium, magnesium and calcium. I will highlight some important points of this slide, but what you have to do is you need to read all the points strictly and make your own notes from these points. Number 1 is the role of sodium and potassium. An average human body having 0.07 kg of sodium and 0.05 kg of potassium. What you need to learn is, what you need to remember is that sodium ion is extracellular while potassium ion is intracellular. This is the very important point. Second is the maintenance of normal hydration and osmotic pressure. Yes, sodium and potassium together maintain the osmotic pressure. Third is the sodium and potassium are the important in maintenance of normal neuromuscular irritability and excitability. To maintain the proper viscosity of blood, what you need is sodium and potassium. So this is also the important point. The ratio of potassium to sodium ions in human beings in human body is 7:1, and this ratio is known as concentration gradient. You have to remember this point. The ratio of potassium to sodium ion in human body is known as concentration gradient. Many enzymes are catalyzed by sodium and potassium ions. This was all about sodium and potassium ions. Now the role of calcium ions. As you know, in the mineralization of cartilages into bone, calcium ions helps, and this is the very important points. So mineralization of cartilage into bone. Calcium is also important for the growth. Ionic calcium helps in the production of thromboplastin and in the conversion of prothrombin into thrombin. For the coagulation of blood, what you need is the calcium ions. Without calcium ions, the blood coagulation cannot be done. Next is the calcium acts as a brilliant activator for enzymes. Calcium ions also helps in the release of acetylcholine, a chemical messenger, a chemical which releases from the nerves ending. Calcium is also essential for the excitation of nerves. When you talk about the polarization, depolarization in case of nerves, calcium is the essential factor which plays an important role. This was all about calcium ions. Last is the role of magnesium ions. Magnesium ions serves as the activator of many of the important enzymes including enolase, peptidase, alkaline phosphatase, RNase and DNA polymerase. It exerts an effect on neuromuscular irritability and high level inducing depression. It was your PYQ for GATE, that is, it exerts an effect on neuromuscular irritability and high level of inducing depression. This is very more important point. In the body, magnesium ions and calcium ions acts as antagonist. This is also very important that magnesium and calcium ions acts as the antagonist to one another and counteract certain effects of one another. And last point is the magnesium ions are present in chlorophyll. That's why they plays an important role in case of photosynthesis. It was all about magnesium ions. We have studied the biological role of sodium, potassium, magnesium and calcium. Now, in case if you are new here at our YouTube channel Gurmantra Shiksha Ka Granth, please do like, share and subscribe. You can also join our Telegram channel for more new updates related to your upcoming exams. You will get free PDF, you will get free notes at this Telegram channel named Gurmantra. For any further queries, please mail us on tanejanehaofficial@gmail.com or you can also contact us on the given number. Thank you very much.